have no question, if you have a question, you can stop me. Yeah. Ask me some questions. Yeah. Otherwise, I try to follow the plan. All right? Yeah. Today, although the first class, we probably a little slower than my original plan. Yeah, that's normal. Yeah. All right. Then, the next topic, I want to show you a concrete example, showing you strategies, executions. Yeah. We want to see it. Yeah. So I use the famous fake coin problems, strategy for fake coin problem. Okay. Yeah. So I think most of you heard of that. It's a puzzle problem. Puzzle. Okay? Yeah. Before we learn any algorithm knowledge, the puzzle problem. Okay? All right. So the first fake coin problem from our textbook. Yeah. We know there are several versions of fake coin problem. Yeah. Here we take a relatively simple version, fake coin problem. Fake coin problem with a lighter fake. The fake one is lighter than the normal coin. Assumption. Okay? Because there is another version, much more difficult. The fake coin, we don't know lighter or heavier. We just know it has different weight from the normal. Different weight. And that's the only information we know. But here, we assume the fake one is lighter. That's easier, yeah, for us. All right. The question. You have n greater than 2, at least more than 2 identical looking coins. And a 2-pane balance scale with no weights. No weights. If you have weights, then much more easier. No weights. All right, yeah. One of the coin is a fake, lighter than all the other coins. Yeah, the genuine coins, right? So here, the question, how to use the minimum number of weighings to find the fake coin? Yeah, that's the question. Minimum number of weighings to find the fake coin. Yeah. Yeah, let me check a little bit. My recorder, yeah. Yeah, I hope it's all right. Yeah, still, okay. Looks fine, yeah. All right. All right, the puzzle problem. Yeah. Here, the reason I put this question at this point, because we don't need the knowledge about algorithm, right? Yeah. Just use our real world knowledge, our common sense knowledge. We can solve it. Yeah, weighing, right? Pen, scale, balance. Everybody knows how to do it. Yeah. So we don't need any special knowledge here, right? Yeah. But I use this as an example. We look at from strategy aspect, execution aspect, right? Yeah, yeah. That kind of thing give you first view, first concrete view of algorithms. Yeah. All right, strategy, the first thing. Yeah. Yeah. At this point, we can think about the strategy. Can you think about, first, in the first view, this problem may not be very easy to solve, right? Think about, at least you need to do some non-trivial work, right? Non-trivial, right? You cannot say it's trivial to solve, right? Non-trivial. You need to do some work. Yeah. Now, think about, we want some effective strategy in this situation. Based on your personal experience, what kind of strategy you want to apply here in this puzzle problem? Yeah.
I would start by weighing like a random subset of the coins.
Okay.
If they all have the same weight, then we know that they're the real coins because only one is lighter than
right.
the fake one.
Right, right. Yeah. Good. He gives me some idea, right? Yeah. He gives me some idea.
Okay, I guess this only works if you have like an even number of coins, or I was just wondering, could you put more than one, like split it half and half and see which one?
Yeah, yeah. Any number. You can put any number of coins, two sides of the scale. Yeah. But definitely you want to put the same number, right? Otherwise, you don't get useful information. Think about it, right? 3 here, 2 there. Can you get helpful information? You cannot. You have to put same number of coins at two sides. Yeah. All right. All right. But here, let me summarize. So what the suggestion from you basically, you told me doing experiments, right? Doing experiments. Yeah. What kind of experiments? So you just play around, try many times doing experiments. Right? That's typically for a typical problem solving for a human. How do we solve real world problems? Usually when we do not have a lot of experience, we do experiments, right? Yeah, that's the typical way we solve real world problems. Play around, try to get some useful information when we manipulate, right? Yeah, typically that, yeah. But one thing, the negative side of that way, it takes a while, right? No. You need to build up your experience. You need to build up your knowledge. When you play around, when you do the experiments, you build up your knowledge. Okay? Yeah. That takes time. Yeah. How about another way? Okay? How about another way? Yeah. We try to save that time. We try to save that experiment time because very time consuming. Okay? How about someone teach you some knowledge already based on a lot of other experiments in the real world? Yeah. Give you some effective suggestion, but that suggestion is based on many other real world experiments. And it is proved very effective. When you apply that, can you save some time? Yeah. So that's what we are going to do in this class. We want to learn many effective strategies based on the real world, a lot of experiments from the real world, other people, experiments. So we do not need to repeat those experiments to get those strategies. All right, so here, let me give you the first strategy that can save our some time, experiment time. All right, yeah. All right, experiments for the experience. Yeah. We want to save as much as we can this time. Yeah. The first thing is try to solve the problem when n equals 3. Is that easy? You only have 3 coins. Is that easy to solve? Same problem. But 3 coins. Minimum number of coins. N greater than 2. You cannot use 2 coins, right? The minimum is 3. Minimum number. This strategy looks nothing brilliant, right? At least you cannot say this strategy is a brilliant strategy, right? Too simple, right? Too simple. Can we call it strategy? It's so simple. Can we call it a strategy? Or if you call it a strategy, anything can be a strategy, right? Any method can be a strategy. Yeah, we can call it strategy. Is it effective? Because the most important question is that effective? Right? Yeah. So here, actually, it's a really effective strategy. Simple or not, that's not important. We just want some strategy effective. Okay? Simple or sophisticated, that's not an issue. So we want an effective strategy. And this strategy is proved extremely effective in many of the real world situations. Solve the simplest case first. Always start from the simplest case. Okay? Yeah. Yeah. Why it's important? First, it's like an experiment, right? But when you do experiment, do you want to get a star started with a very simple case or very difficult case. Here, why, starting from the simple case is important. We want experience. We want some relevant experience. Yeah.
I was thinking if instead of n equals 3, if we had n equals 9, could we like split it into groups of 3 coins and then just compare the 3 groups? And
Yes.
turn it into the simple case.
Great. That's the essence of this method. We divided all our coin into 3 piles, 3 even piles. Or we say 3 even piles. Okay? Why 3? Why not 2? Why not 4? Why 3? Why 3 is the magic number? Can you imagine that? Here, 3 is the magic number. Can you imagine that? Yeah. Yeah. Actually, you can, because based on the device, the scale, 2-pen scale, okay? 2-pen scale. Basically, one weighing of a 2-pen scale can give us 3 different information pieces. 3 different. Left pen information, right pen information, and off the pen information. How about that? Off the scale, right? So basically, we can collect information from 3 different places. Left pen, right pen, off the scale. That's the reason we divide into 3 piles for 3 parts of the information sources. How about that? Okay, yeah, so 3. Yeah, good, simplest case. All right, now let's do the work. N equals 3. Do the work. Yeah, yeah, I think, so everyone, you can do it. Yeah, but here, if you do it in your mind, it may not be easy, but let's do on paper. Yeah, we assume this is paper. We do on paper. Okay, all right. 1, 2, 3, 3 coins. Yeah. Now we put it on a 2-pen scale. Yeah. Coin 1, coin 2. Put 2 sides of the scale. There are 3 different cases, right? Yeah, 3 different cases you need to study. Okay. The middle one, even. Okay, yeah. Even. Which one is the fake? Is coin 1 fake, coin 2 fake, or coin 3 fake? Yeah, coin 3. Yeah. How can coin 1 fake, right? If coin 1, how about same weight, coin 2, right? So coin 3 is the fake. Okay? All right. Then, yeah, 1 weighing, we know coin 3 is fake. Then for the first uppercase, yeah, that's the result. Then you can easily see coin 1 fake, right? The lighter one, yeah. Similarly, the last case, coin 2 fake. Yeah. 1 weighing, 1 weigh, yeah. So yeah. What? Yeah. We can get all the information for n equals 3. All right. Yeah. Here, let me do the summary. Yeah. Yeah. Because we near the break time. Let me do the summary for this method. Then we take a break. Yeah. All right. After you study this first special case, it's very easy. I believe everyone in this class can do it. Yeah. Suppose I assign you this problem, n equals 3. Use 1 weighing to tell me which one is the fake. I believe everyone can tell me how to do it, right? Just do some experiments, then you will figure out immediately. Yeah. But the most important thing is, what do we learn from this simple example, right? Does it help? Does this simple example help us to solve when n equals 100? Does it help solving? Yeah, because our goal is for general n, not for this special case. Yeah. You told me 9, right? Yeah, we can solve 9 coin problems. 9 coin problems. Can you tell me how many ways you need weighing 9 coins?
So yeah, you split each coin into a group of 3 so you can find which group has the lighter one, and then it reduces down to 3 coins, could be the fake one, and then you do the process again. So you're sort of like repeating the process 2 times.
Right, yeah. 2 weighing, so you can fix 9. Can you solve 27 coin problem? Right? 27, can you tell me how many weighings?
You divide it into
27? Yeah.
sets of 9,
Right.
and then do the same process.
Right. 1, 2, 3, right? Yeah. So you get the rules, right? You get rules. So here you know the purpose why we do experiments for the simplest case. Because we can get a lot of helpful information from that simple case. Yeah? Because after you work it out, we as a human, we find some general rule behind it. That's the reason simple case is useful. Yeah, simple case because we can see something unseen before, right? We can see something. If we do not do this experiment, we never know, right? If we do not solve it, the simplest case, we never know, right? Yeah, so here you can see the power. We can call effective, right? The strategy effective. Later you will see many other, many difficult problems. If we do it in this way, much easier. Much easier. Okay, that's why this is an effective strategy. Okay, yeah. Many times people tend to feel if some strategy is extremely simple, some kindergarten kid can do it, then we feel it's a bad one. Because if a kindergarten kid can do it, why it is a good strategy, right? People tend to feel about that, right? But it's not, okay? It's not. Yeah. Our standard, it's not a kindergarten kid or not. Our standard is if it is effective or not. Okay? Yeah. If it's effective or not. That's our standard. Yeah. Okay? Yeah. All right. Yeah. So I think it's a break time. So come back at